Chapter 13, number 43. Two people with a combined mass of 125 kilograms hop onto an old car with worn-out shock absorbers. This causes the springs to compress by 8 centimeters. When the car hits a bump in the road, it oscillates up and down with a period of 1.65 seconds. Find A, the total load supported by the springs, and B, the mass of the car. So the basic idea is that the shock absorber looks something like we have the wheel, and then essentially a spring connected to a platform. And now we're going to say on this platform is some mass m. And of course the spring has some constant k. And when you hit a bump on the road, the wheel goes up and the mass stays in place, and then the wheel gets pushed back down, but it's still simple harmonic motion. So we're going to use the mass period relationship, which connects the period to the mass and the spring constant. But we don't have the spring constant. We're going to get the spring constant by using this part of the problem. That when they first get on the spring, the additional mass of the two people, which I'm going to call M0, let's call this guy, let's call that M0, which is 125 kilograms. And the basic idea is that if we think about the spring with the extra bit, the additional weight M0G has to be made up by the additional stretch in the spring, or compression in this case in the spring, because they have to come in balance. And because we think about the spring, it's got an extra weight pulling down and an extra force that has to put them in equilibrium. So this lets us say that the spring constant is M0G over delta S. So this is 125 kilograms times 9.81 meters per second square over 8 centimeters, which is 0.08 meters. And so we get, this is 15328 newtons per meter, which is right ballpark actually, about 10,000 newtons per meter is the usual shock absorber. And now we can go back and we can figure out the total mass of the weights on the spring. So we can say, using the period relation, we can say T squared is 4 pi squared m over k, so that m is kt squared over 4 pi squared. So it's 15,328 newtons per meter times 1.65 seconds all squared over 4 pi squared. Be careful when you enter this in the calculator that you put parentheses around the 4 pi square, or you'll get something off by a factor of about 16. This comes out to be a mass of about 1,057 kilograms. M is that. Which, because we have only 3 sig figs, this is really 1060 kilograms. Of course, M is the mass of the car plus the mass of the people. So the mass of the car is the difference between what we just found and the mass of the people. So it's 1060 kilograms minus 125 kilograms, which is 935 kilograms. We have to keep in mind that this is not significant, so really it's 940